Problem number 1, geometry, 4th 6 weeks test review. The vertices of a quadrilateral, MNPQ, what is the most precise calculation of MNPQ? Okay, so what we need to do is find the distance, the lengths, and the slopes of each of these edges. So I'm going to set up a table. We're going to find MN, we're going to find MP, we're going to find PQ, and we're going to find QM. We're going to find the slope, and we're going to find the distance. Now then, to find the slope, remember the slope is y minus y over x minus x, which I'm going to abbreviate as delta y over delta x, change in y over change in x. And in your distance formula, you do x minus x squared plus y minus y squared. That's the same numbers here in it. So it's delta x squared plus delta y squared. So we're going to use this delta y and delta x in our slope in our distance formula. Okay, so let's do MN first. To go on MN, we're going to go from 4 to 7. The difference in y would be from 4 to 7. You would go from 4 to 7, you would go up 3, wouldn't you? So our delta y, and I'm going to put it up here, delta y would be 7, wouldn't it? And our delta x from negative 14 to 1, from negative 14 to 1 would be 15, wouldn't it? Okay, so it would be 7 over 15. That would be the slope. Now that if we plug these numbers into the distance formula, we would get 49 and 125, wouldn't we? And if you add those up, you get 174, which would be the square root of 174, wouldn't it? Now then, let's go to MP. From 7 to negative 9, 7 to negative 9, you're going down 16 units, aren't you? So it's going to be a negative 16. And then you're going to go from 1 to 3. From 1 to 3, you're going right to a positive 2, aren't you? That's going to simplify to a negative 8. But your distance formula, you'll do 16 times 16 and 2 times 2. 16 times 16 is 256, and 2 times 2 is 4. If you add those up, you get the square root of 260. Okay, let's go to PQ. We're going from negative 9 to negative 12. Negative 9 to negative 12, you're going down 3. Okay, so our slope is negative 3. From 3 to negative 12. 3 to negative 12 would be to the left 15. So negative 15. That slope would be 1 over 5, wouldn't it? Notice that none of these are parallel yet, or perpendicular. Okay, now then 3 times 3 is 9. From 4 to 7, that should be 3. MN should be 3 right here, shouldn't it? From 4 to 7 and then 15. So this is 3 over 15, I'm sorry. So MN should be 3 from 4 to 7. And then you would get 3 times 3 is 9. 15 times 15 is 125. That's going to be 134. Okay, so these two slopes are the same, aren't they? Sorry about that. And this is going to end up being the square root of 134, isn't it? And then let's go from Q to M. From negative 12 to 4. From negative 12 to 4 is going to be up 16, isn't it? So our 16 repeats. And then we're going to go from negative 12 to negative 14. We'll go back 2. That's going to end up being negative 8, isn't it? And these numbers are the same. You'll still get a square root of 260. Notice the opposite sides are the same. So that eliminates a squared aramus, doesn't it? Okay, and then the slopes are not perpendicular, are they? Okay, so technically, this is none of these. It's going to be a rectangle, or I'm sorry, a parallelogram, isn't it? Now then, more precisely on that, it would be a rhombus if you had to do it, because it's not a kite or trapezoid, and it is a parallelogram, isn't it? But their sides aren't the same. So it would be a parallelogram, or in this answer choice, it would be A.